Okay, before I get into this lesson proper, we are now in a section where we're combining both our learning from before. So everything we talked about in terms of osmoregulation, thermal regulation, endocrine system, and nervous system, we've talked about them separately as discrete parts of homeostasis, when in truth, they're all interwoven together. So I'm going to kind of back up and then come forward in order for us to better understand the concepts that go with this week. So one of the first places I want to talk about is the idea of osmoregulation. So we've done osmoregulation, we've done endocrine system, so you think that was done. But at some point I'd mentioned to you this concept here known as RAS, right? And RAS stands for renin, angiotensin, aldosterone system. And the reason why I'm coming back to this is because it ties in with our concept for the week. Okay? So I'm going to diagram how this particular hormonal osmoregulatory system works, and then I'm going to go into the lesson proper, and hopefully the story at the end will make more sense. So somewhere in your nephron, near the initial capsule, the Bowman's capsule here, there's a receptor. And that receptor, what it does is it will measure the blood pressure. So as the blood comes in, right, to the afferent, does this whole thing in the glomerulus and leaves. I have this in the wrong spot here. So in this area here, there's a receptor that measures the blood pressure. And if the blood pressure is too low or too high, then information goes to the brain. And from this, we get the release of a particular hormone, a chemical that is going to have an effect in the body. Floating throughout your blood, we have this other chemical known as angiotensin. So angiotensin. So this is created by the liver, and it is then released into the blood, and it is just floating around your blood supply. And the renin that's released by the kidney is going to come along and do something to the angiotensin that's released by the liver. It's going to cause the angiotensin to transform into a new chemical known as angiotensin 1. And this angiotensin 1 is converted thanks to renin. So the renin, which is released in response to low blood pressure, will cause the conversion of angiotensin, which is floating around the blood, into angiotensin 1. And then the angiotensin 1, it will be converted thanks to something called the angiotensin converting enzyme. We call it ACE for short. So the angiotensin converting enzyme, also floating around the blood, is going to convert the angiotensin 1 into angiotensin 2. So I didn't make this up, I'm just explaining it. So here's the process. Now this angiotensin 2, when it's created, it will have a direct effect on the blood vessels. So it directly impacts the blood vessels, causing them to constrict, and it increases the cardiac output, which allows the blood pressure to increase. It also has an effect on other parts of the body as well. The angiotensin 2 will affect the adrenal gland Oops. So here we are in the adrenal gland. And I'll cause the adrenal gland to release a hormone known as aldosterone. And the aldosterone will therefore then cause the nephron to absorb sodium in greater volumes. So if I go over here to the nephron, right, and we'll drop into our loop of Henle, goes up, does its thing. So the sodium will be reabsorbed thanks to the aldosterone. That's what the aldosterone does. The aldosterone causes this reabsorption to occur. And we know that from our osmosis and our osmoregulation, if sodium gets reabsorbed, then we're going to have a greater increase of water because the water will follow. So the aldosterone causes a greater increase of sodium and therefore a greater reabsorption of water being reabsorbed. So water retention is greater thanks to aldosterone. The angiotensin will also cause the release of ADH, which is in the brain. And so the ADH, we know what that does. The ADH will circulate through the body. It goes to the nephrons as well. And I didn't talk about this mechanism before, but it specifically causes the aquaporins, very special channels, to become inserted into the nephron, and then that causes more water to be reabsorbed as well. Okay, so the angiotensin causes the ADH to be released. It directly impacts blood vessels, making them thinner, constricting them. It increases cardiac output, and it causes the release of aldosterone. So this system here is known as the renin, angiotensin, aldosterone system, which helps increase water. Okay? So that's an important learning for this concept. It's kind of like a prequel, something that I missed. Not really missed, but it sets the stage for something I'll talk about in this lesson. Now, in our lesson, we are looking at the mechanics of the nervous system and the endocrine system and how they work together in order to prepare you for this particular response. And the response that we want to look at, well, it involves these. So let's look at the overall structure here. So I have to come back to this. So we have the central nervous system that's made up of the brain and the spinal cord. And the brain and the spinal cord together control the peripheral nervous system. The peripheral nervous system has sensory neurons that bring in information, environmental stimuli into the brain so it knows what's happening in the world. And then the brain then reacts through motor fibers. And these motor fibers, some go to your skeletal muscles, some go to your other muscles, the muscles that control your blood vessels, whether or not they constrict or dilate, your cardiac muscles that determine whether or not your heart's going to pump faster or slower, your glands, whether or not they're going to release some hormones that allow you to react a certain way. And these two systems here, we have the somatic system, which you have control over, and the autonomic. I like autonomic. I think of automatic, the things you don't have control over. And in the autonomic nervous system, there's both the sympathetic and the parasympathetic nervous system. So we are focusing on those two today, the sympathetic and the parasympathetic. So if we look at this graphic here, we can see the two components of the autonomic system here. One of them is the parasympathetic, and the other one is a sympathetic. Look at the sympathetic, and it gets innervated and activated. It causes your pupils to dilate. It causes your saliva and your digestive processes to shut down. It causes your bronchi to open up and your heart rate to accelerate. It releases epinephrine or norepinephrine, also known as adrenaline. It causes your liver to break down glycogen into glucose. Okay? The opposite reaction here, the parasympathetic, it does everything the opposite. Whereas the sympathetic causes your pupils to dilate, your pupils constrict. Where your digestive system was inhibited, here your digestive system is activated. Where your heart and your lungs and everything were ready to get you as much air and energy as possible, now it's back to normal and it slows your heart rate down. Okay? So the sympathetic and parasympathetic nervous systems are opposites. They have opposite roles in the autonomic nervous system. At this point, once again, if you've not completed the reading that I told you to do in the lesson, please do. And once you've done that, we can now start into the lesson.